All right, let's dive in. Today, we're going to talk about a really exciting new AI framework that could totally change how language models think. It's called Calm. And believe me, it's a huge deal because it tackles one of the most annoying things about AI right now, raw speed. You know that feeling, right? You ask a chatbot something, and then you just wait. You're watching that cursor blink as it spits out the answer, one single word at a time. It's kind of painful, and it feels slow for a reason, because it is slow. So what's going on under the hood? That's exactly what we're going to unpack.
Okay, so this slide just nails the difference. On the left, that's how things are now. The cat sat, one piece at a time. But look at the right. That's the Conway way. It's thinking in chunks, like the cat sat and on the mat. We're going from this long, drawn-out sequence to a much, much shorter one. And that simple idea, well, that changes everything.
All right, first up, the AI speed limit. To really get why Calm is such a game changer, we got to talk about what's been slowing these models down in the first place. So, the heart of the problem is something called the token bottleneck. Here's how it works. Every single time an AI writes a word, or even just part of a word, a token, it has to stop and think. And what's it thinking about? It's looking at this massive dictionary, a vocabulary with anywhere from 32,000 to over 250,000 options, and it has to pick just one. And then it does it again for the next word, and the next. It's an insane amount of work for each step, like a massive traffic jam in its brain. And here's the crazy part. After all that work, after searching through 250,000 options, the actual amount of information in that single token it spits out, it's tiny, just 15 to 18 bits. There's this huge disconnect, right? We've built these incredibly powerful, gigantic AI brains, and we're forcing them to do this really low bandwidth task. It really is like using a supercomputer to add 2 plus 2 over and over again. It's just not efficient. So what's the fix? Well, if the problem is thinking one word at a time, the solution seems kind of obvious, right? Let's get it to think in bigger pieces. And that's exactly what Calm does. This is the big idea, the paradigm shift. We're moving away from individual words and into a whole new way of representing language.
So here's the official definition: continuous autoregressive language models. But what does that mean? Well, instead of predicting the next word, Cal looks at a chunk of words, let's say 4 of them. It then learns to predict the vibe, the essence of that entire chunk, all at once. And it represents that essence as a single mathematical thing called a continuous vector. It's a total change in perspective. I love this quote from the researchers because it just makes it so clear. Traditional models, they're like someone typing with just 2 fingers. One letter at a time. Super slow. Calm, on the other hand, is like thinking of the whole sentence and just writing it down. It's about flow, it's about efficiency, it's about generating whole thoughts, not just single letters. Okay, so this all sounds great, but how does it actually work? I mean, how can you squish a bunch of words into a single mathematical point, a vector, without losing all the meaning? Well, the magic ingredient here is something called an autoencoder. Think of it like a 3-step dance. First, you have the encoder. Let's call it the chunker. Its job is to take a group of tokens, a phrase, and compress it, squish it down into one single dense vector. Now that vector is special. It holds the core meaning of that phrase. Then, step 3, you have the decoder, or the unchunker. It takes that vector and, poof, it unpacks it, perfectly rebuilding the original words. And when I say it rebuilds them perfectly, I'm not kidding. Look at that number. Over 99.9% accuracy. This is absolutely critical. We're not talking about a blurry summary here. This isn't like a low-res JPEG of the text. This is high-fidelity, nearly lossless compression. But, and this is a really clever part of the research, perfect reconstruction is only half the battle. You also have to make sure that the mathematical space where these vectors live is, well, smooth. If it's too brittle, then even a tiny little mistake in prediction could send the whole thing off a cliff into gibberish. So they had to make it robust, stable, a good place for the AI to actually learn and make predictions. Okay, so now we've got these awesome compressed vectors, but this solves one problem and kind of creates a new one, a really fascinating one actually. How on earth do you predict the next vector when you're choosing from an infinite number of possibilities? No, seriously, think about that for a second. With the old token method, you're picking a word from a dictionary. It's a huge list, but it's a finite list.
In this new vector world, it's a continuous space. There is no list. There are infinite points. How do you possibly pick the right one? The answer is a very specialized piece of tech called the energy transformer. This is the engine that makes it all work. It's designed to predict that next vector directly, in one single shot. And this part's key. It avoids all the slow, step-by-step sampling methods that other models have used. Because if it was slow, that would kind of defeat the whole purpose, right? All right, so the theory is all there. We compress text into vectors, and then we have this cool energy transformer to predict the next vector. Sounds good on paper, but does it work in practice? Let's get to the good stuff, the payoff. And the headline benefit is just wow. It's simple math, really. Because Calm is grouping K tokens into one step, it's reducing the number of steps it has to take by a factor of K. So if you're chunking 4 tokens at a time, what they call K equals 4, you're potentially getting a 4 times speed up. That is huge. And it's not just theory. The data proves it out. Just look at this chart. We're looking at computational cost here, flops. The Cal model gets basically the same performance as a really strong baseline model, but look, it does it with 44% less computational work. So it's not just faster to run, it's way, way cheaper to train. Now check this out, because this is where it gets really interesting. This table shows how well Calm scales. Look at the Calm model on the bottom. It has more than double the parameters of the baseline transformer. It's a much bigger model, but it uses significantly less power for inference to actually run. And the performance is even a little bit better. This is exactly what everyone in AI is looking for. Bigger, more capable models that are actually more efficient to use. And that really brings us to the big picture here. What we're talking about with Calm isn't just a little tweak or a small improvement. This is a potential shift in the entire philosophy of how we build and scale these massive AI models. Yeah, the researchers said it best. For the longest time, the mantra in AI has been go bigger, more parameters, more data. That was the only way to improve. What Calm does is it introduces a whole new design axis, a third knob to turn. Instead of just scaling size, we can now scale the information capacity of each prediction step. This semantic bandwidth is a powerful new tool for making AI better and more efficient. So let's wrap this up with the key takeaways. First, this is a real paradigm shift. We're moving from individual, discrete tokens to these continuous vectors that represent whole chunks of text. Second, the efficiency gains are dramatic. We're talking K times speed up without losing quality. And finally, and maybe most importantly, this gives us a brand new scaling axis, a new way to optimize AI that goes beyond just making them bigger. And that really leaves us with a pretty mind-bending question, doesn't it? If we can teach an AI to stop thinking in single words and start thinking in sentences, what's next? Can we get it to think in paragraphs? Or even in whole abstract concepts? It really feels like we're just scratching the surface of what might be possible.